Yeah, thank you. Yeah, now my voice is audible. Please check.
Yes, sir.
Okay. Now check PPT is also visible.
Yes, sir.
Sir.
Yes, PPT is visible.
Yes, sir.
Okay, ma'am. Yeah, first, in order to determine the speed and height of the governor, first we'll go for use this method of resolution of forces, the analytical method. Again, for subject point of view, this method is not there for your syllabus. Now we'll move on to the second one. Second one, instantaneous center method. Has you heard about this word instantaneous? Yes, give me response. Instantaneous. Yes, please check. My voice is audible. Yes, someone has to give me response. Yes, please check. My voice is audible.
Yes, sir.
Yes, sir. Audible, sir.
Okay. Yeah, next second method is instantaneous center method. So in this, as you know that what is by instantaneous at particular time. Okay. So what will be the position of the link or the mechanism is occurred, and if you consider any parts of the mechanism, okay, you can see that particular time what will be the center it is. If the center, for example, if a crank is rotate about the center, right? If you go for slider crank mechanism, now for the each link, if you go extend that each link of the mechanism, one link is extend that link length, and another side also extend the another link length. Those two link is intersect here. That point is called as a instantaneous center, means that about that point only the link is rotating or moving occurred here. That called as instantaneous center. Here for a porter governor, you can see that we'll consider only off portion on the left side portion here. Now you can see the OAB. O is stands for pivot point at the upper arm and the governor shaft axis. Point A is nothing but a governor ball is attached here. Point B is nothing but the weight of the sleeve acts at the point at this point B. Now see the OAB or BAO. Now as this upper arm moves radially outward or inward, at point B what happens? It moves upward and downward direction. Means it's a reciprocating motion. Here OA moves angular motion. Means what type of mechanism it is? A slider crank mechanism. At point B it slides here. At point the AO link, that upper arm link is undergoes a rotary motion. That's called the slider crank mechanism. See that. Note BAO is a kinematically equivalent to a slider crank mechanism with B as a slider that's in vertical position. Then I want to determine what will be the instantaneous center for this connecting rod AB. Connecting rod AB, what will be the instantaneous center? For that, what I will do, I will go for extend this OA, the upper arm link length, extend this line, extend that line, dashed line, extend it. And from point B, it is a slider. The point B slide moves here, draw a line which is perpendicular to the point B. Means draw a horizontal line, there's a dashed line. That OA, extension of OA line and a line which is perpendicular to the shaft axis from the point B, horizontal line. That those two line intersect that point is called as a I. That is called as instantaneous center for this link AB. Okay, the link AB is located
Sir,
in,
ವಾಯ್ಸ್ ಕರೆಕ್ಟ್ ಏನು ಕೇಳಿಸ್ತಿಲ್ಲ ಸರ್.
okay, voice is not audible. Yes, forgive. Yes, now my voice is audible.
ಎಸ್ ಸರ್, ಆಡಿಯಬಲ್ ಸರ್.
Okay. Yes, Chandan BM. Chandan BM.
Yes, sir.
Yeah, so now here I'm showing you're the host. Okay, do one thing, ma. Some more option is there or dotted option is there. Check in your mobile.
No, sir.
No?
Yes, sir.
Yeah, go
Yes,
to
sir.
there. Click that.
Yes,
You
sir.
can see that the sharing option, share to others, is there.
No, sir. Share to others.
Sharing option is there. Check, that is sharing others.
No, sir. Share whiteboard is there, sir.
Say whiteboard. Okay. See there in that. Okay, anyone knows that how to share others?
Sir, meeting setting.
ಹೋಸ್ಟ್ ಮಾಡಲಿ. ಹೋಸ್ಟ್ ಮಾಡ.
Host is disabled participants in. Yes. Or else you log out, ma. Chandan, again you log out and log in. Now my voice is audible.
ಎಸ್ ಸರ್, ಆಡಿಯಬಲ್ ಸರ್.
Okay. I think today we are facing so many disturbances due to maybe internet issue. Yeah. Yeah, now see that here. Now extend this line OA. Extend this link OA. There's a dashed line from the A, and from the point B. There's a point B. It is slide. It is slide here. It moves vertically up and down, and draw a line which is perpendicular to the movement here. That a horizontal line. The intersection of AO, extension of OA line, and a line which is perpendicular to the point B or perpendicular to the axis of rotation. Those two lines intersect at point called as a high, that is called as a instantaneous center for the link AB. Now my voice is audible. Yes, give me response.
ಎಸ್ ಸರ್, ಆಡಿಯಬಲ್ ಸರ್.
Okay.
ಆಡಿಯಬಲ್ ಸರ್.
Yeah. So after that, once you get the instantaneous center I, now from point A, I draw a vertical line. Why you draw a vertical line here? The mass of the governor ball acts vertically downward. Mg it acts vertically downward. Draw a vertical line that intersect the BO BI line. BI line, that intersect point is called as D. That intersect point is called as a D, right? From point A, I draw for first one from OA, OA link, then you go for extend that OA link, and then from point B that moves vertically upward and downward. From point B, draw a line which is horizontal line, that intersection of the extension of OA and the line which is passing from B vertical to the shaft axis. That intersection point is called as I. From the point A, I draw a vertical line, that is Mg is acting vertically downward. Then extend that line, that intersection of BI, that point will called as a D. Okay. Then as you know that angular position, the upper link with respect to governor shaft axis, that angular position is alpha. Then this is also a alpha due to alternate angle, and lower arm with respect to the governor shaft axis, this angle is beta, and this is also a beta because this is also alternate angle, right? and this angle is alpha. What about this also alpha? Or this is alpha means, what about this also alpha? Now what type of angle it is? It is called as the corresponding angles, right? Now as you know that the height of the governor is, it is a vertical distance from the upper arm pivoted to the shaft axis to the radius of rotation of the governor ball. That height is called as a height of the governor. That vertical distance is called as the height of the governor H. At the same time, from the lower arm, we consider from the lower arm, the vertical distance from the lower arm to the governor balls rotate. That the vertical distance at the lower arm will called as a A. Okay. Then the distance between BD, that point that is called as a BD is called as B, and distance between ID will called as a C. Now what will be the radius of rotation of the governor ball from the governor shaft axis to the CG of the governor ball? That radius of rotation will called as R. Now at governor ball, what are the forces acting? One is mg is acting vertically downward, and due to rotation of the governor shaft axis, a centrifugal force acting over the governor ball, that is mr omega square. At the sleeve, which is on the one side, it is fixed at point B, that is, what is the weight of the sleeve acting here? Vertically downward, that is capital M G by divided by 2. Now these are the notations, and how do you represent all the things, you should know it. Okay. Now we consider only the left side portion here. Left side portion of the porta governor, or else you also consider right side portion also. Any one portion will consider here. These are the forces acting at the governor ball, and these are forces acting on the weight of the sleeve is acting at the point B. Okay, then our aim is to determine what? The speed of the governor shaft and height of the height of the governor, right? Yes. Now how do you determine height of the governor? So for that, 1 minute. For that, I will take this sketch. Yeah, now this slide is visible. Give me response.
Yes, sir. Visible, sir.
Yeah. Now, how do you determine this height of the governor H? From once you determine H, then you can easily determine the speed of the governor. Or once you determine speed of governor, then you can go for determine height of the governor. How do you determine here? Now, considering again equilibrium equation, considering the equilibrium of the left hand half of the governor by taking moment about I. Now take this moment about I. Whenever the vector sum of all the moment about an arbitrary point I equal to 0. Now what I will do, we'll go for take the sign convention. Clockwise movements are positive, then counterclockwise movements are negative. Counterclockwise movements are negative movements. See that vector sum of all the moment about I is equal to 0. Then what is the sign convention? Clockwise movement are positive, counterclockwise movements are negative. Now what do you mean by movement? Movement is nothing but what? Force into perpendicular distance, right? Movement is nothing but force into perpendicular distance. Be careful about this. What distance here? Perpendicular distance. Force into perpendicular distance. Now tell me what are the forces acting on the here? How many forces are acting here? One is centrifugal force acting from the governor ball. Another one is the weight of the governor ball acting. Mg is acting, and one more force is the weight of the sleeve acting here. These are three different forces acting on the governor. On the governors on the left side you consider here, right? Now the first you consider governor ball. One is centrifugal force mr omega square that acts here radially outward this direction. What is the perpendicular distance? Perpendicular distance between AI. AI is nothing but perpendicular distance between AI is nothing but AD. That is what? That is nothing but A. Movement is nothing but force into perpendicular distance. This is mr omega square into A. Now that produces what type of couple here? That produces what type of couple? Counterclockwise couple, see that m r omega square into a force into perpendicular distance, negative sign. Why do negative sign here? We consider negative sign because counterclockwise couple are counterclockwise movements are negative, right? And second force is mg. Mg is acting vertically downward. What is the perpendicular distance? Mg acting vertically downward. What is the perpendicular distance here? C, right? Mg into C, that produces what type of movement? A clockwise movement about I, about point I. It produces a clockwise movement, that is force into m into g. There is a force into perpendicular distance is C, the force into perpendicular, that get movement. That what is the symbol here? That produces a clockwise movement, that is a plus symbol you get. Next, one more force here, one more weight is acting, one more force acting at the point B, that is a sleeve weight. How much here? Mg by 2. What is the perpendicular distance? B plus C. B plus C, mg by 2, force into perpendicular distance B plus C, that produces what type of movement? That is also produces a clockwise movement, that is mg by 2, force into perpendicular distance B plus C, that produces what type of movement? Clockwise movement. That's why plus symbol you get. That is equal to 0. That is equal to 0. Now this is the equations you got. Is anything, any doubt regarding this equation? If you have a doubt, please unmute yourself and ask me the question. Yes. So movement about any arbitrary point. Here arbitrary point is I, the instantaneous point, equal to 0. That is a Again, sorry for the disturbance. Today again we are getting more disturbances in our internet issues. Yes, my voice is audible. Yes, please respond me. My
Yes,
voice
sir.
is
Audible, sir. Yes, sir. Audible, sir.
okay. Today we are facing so many internet issues. In my side, I think. Yeah. Any doubt regarding this moment equilibrium equation? Yes, if you have doubt, please unmute yourself and ask me that this equation.
Sir, again voice breaking, sir.
Again, voice breaking. Again, internet issues are there. So your internet connection is unstable. Now my voice is audible. Yes, please check. My voice is audible. Just give me response. Just give me response. My voice is audible.
Yes, sir. Audible, sir. Sometimes the voice is breaking, sir.
Okay, ma. So whenever you're breaking, please inform us. Okay.
Okay. Okay, sir.
Okay. Thank you, ma. Any doubt regarding this step? We take a
Sir,
moment.
once more tell me, sir. Sir,
Yeah.
once more first tell.
Okay, so we are taking moment about an arbitrary point about the instantaneous center point, that is I is equal to 0. Now what is the sign convention we are choosing here? Clockwise movements are positive, counterclockwise movements are negative. As you know that what is meant by movement? Movement is nothing but force into perpendicular distance. So how many forces are acting here? One force is a centrifugal force acting is generated from the governor ball. Second force is due to weight of the governor ball. The mg is force is acting at point A. And third one, a sleeve is connected at the point B. That weight of the sleeve is mg. Total weight of the sleeve is mg. That's split into two portions.
Excuse me, sir. Again, same is happening.
Okay. So what we can do? Otherwise, shall I end this meeting?